Hi, this tutorial covers the distribution of sample proportions. Alright, so let's start with the definition. Distribution of sample proportions is the distribution of all possible sample proportions for a certain size n. Alright, so to kind of envision what a distribution of sample proportions look like, consider this. Suppose a coin is flipped 10 times, so in this case n is equal to 10, and the number of heads is recorded. Okay, so let's say that we got 6 heads out of 10. Okay, the distribution of sample proportions would be the distribution of all possible proportions of heads when a coin is flipped 10 times. Okay, so if we got 6 heads, it would be 6 out of 10. So sample proportion, remember we call that p hat, would equal 0.6. That would be one of the possible values on that distribution of sample proportions. Okay, so for any distribution, it's important to consider the distribution center, spread, and shape. So we're going to address each of those things as it relates to the distribution of sample proportions. All right, so if we start with the center, the mean of the distribution of sample proportions is equal to the population proportion. Okay, so the mean of the distribution of sample proportions. So if it's the mean of the distribution of sample proportions, we notate it as mu sub p hat. That's equal to the population proportion. Okay, now this population parameter could be known, for example, if there was a binomial question type and a census of responses could be obtained. Okay, so if you're able to determine the population proportion, we know that that's going to equal the mean of the distribution of sample proportions. Okay, so this is an important relationship here. Mu sub p hat equals p. All right, so that is measuring the center. So now if we think about the next one, the spread, let's first of all define the standard deviation of the distribution of sample proportions. And it is defined as a measure calculated by taking the square root of the quotient of p times 1 minus p and n. Okay, so the standard deviation of the distribution of sample proportions is going to be sigma sub p hat. That's going to equal the square root of the quotient again means division, of p times 1 minus p over n. Okay, so this will give us a way of measuring the spread of the distribution of sample proportions. All right, so we have the center, the spread, and then the last thing we like to talk about is the shape. And like always, we want the shape to be normal. So the distribution of sample proportions is approximately normal, okay, as long as the sample size is sufficiently large. Okay, the larger the sample size, the closer the distribution of sample proportions is to the normal distribution. All right, so to recap, remember that the mean of the distribution of sample proportions is just equal to the population proportion. The standard deviation of the distribution of sample proportions is the square root of p times 1 minus p over n, where p is your population proportion, n is your sample size, and then the shape will be approximately normal as long as n is sufficiently large. All right, that has been your tutorial on the distribution of sample proportions. Thanks for watching.